Hey guys, today we are going to learn about something new and it's called a radian. And so you can write down your essential question. I'm going to actually start this GIF. And this is just what we did in class with the pipe cleaner. So they've taken a circle and they've got a radius r, and they're going to take that radius and make it that arc length of the circle. And so you can see as it goes around, it takes one time, that's a radian. Yeah, it's going to take like a little more than I can explain, like it's going really slow. Okay, there we go. And so now it's got 2 radians and then 3 radians, and then if we get that little extra part of it, that's a pi radian, and that's going to give me that semicircle. So 180 degrees is equal to pi radians. Okay, and so then if we continue around the circle, the whole thing is 2 pi radians. And so really all we're doing today is kind of shifting our focus away from the degrees and into this new thing called the radian. And again, that's just that arc length of the circle that is got that radius instead. Okay, so the first thing we're going to talk about is the coterminal angles. And remember, coterminal angles are just angles that end at the same place. So they terminate at the same spot in the same quadrant. Okay, and so instead of what we used to do, we used to take plus or minus 360, and we'd say, well, an angle coterminal to a 30 degree, we could just add 360 or subtract 360 and do that forever, and that would give me the same thing. Now, if you remember on your circle, and we just saw that animation, instead of going around 360, we're going to go around 2 pi. So now instead of taking a plus or minus 360 degrees, we're just going to plus or minus 2 pi to whatever radian value they give you. Okay, this is an example of a radian, pi over 6. A lot of times you're going to see radians with a pi in them. There doesn't have to be a pi in the radian value, but it's going to be most likely have a pi in there. If it doesn't say degrees though, we know that it's going to be a radian. Okay, so what I want to do here in order to find a coterminal angle to pi over 6 is, remember, I just want to add 2 pi to it. So if I want to add 2 pi here, you're going to notice this is now a fraction plus a whole number. So what we have to worry about with this coterminal stuff is we're going to have to go back to, I don't even know, like 2nd grade, and we're going to have to remember about our common denominators. And that's actually the most tricky part about this. The 2 pi part, you're going to have like back of your hand, but we're going to have to remember to add my common denominator in. Okay, so common denominator is going to be 6 on this guy. And remember, if I times the bottom by 6, I have to times the top by 6 too. So I would be adding 1 pi plus 12 pi. So I would get 13 pi, keep my denominator. So a coterminal angle to pi over 6 would be 13 pi over 6. Okay, or we could go the other way, and I could take pi over 6 and subtract 2 pi, which we just said was 12 pi over 6. And I would see that another coterminal angle would be negative 11 pi over 6. And remember, a negative angle just means that I'm going clockwise instead of counterclockwise. So these are 2 coterminal angles to pi over 6, and I could just continue adding or subtracting 2 pi in order to find more coterminal angles. Okay? The next thing that we really care about is doing some conversions, because degrees are a lot more physically, they make more sense in the real world, whereas radians, we aren't really used to them, so we're not sure what they look like. So if we want to convert my degree measurements to radians or vice versa, we're going to have to know a little bit about them. So the first thing we need to remember, and you probably remember this because we did the whole pipe cleaner thing, is that 360 degrees equals to 2 pi radians. Okay, and then 180 degrees, half of that circle, is just equal to pi radians. And I could continue this trend down and try to figure out what 1 degree was equal to, but I could do something a little bit easier. And what I can do here is, if I know that 180 is equal to pi, and I want to know what 1 degree is in radians, is I could take this 180 and I could divide both sides by 180, because that would tell me that 1 degree is equal to pi over 180 radians. So now I have something that I can use in order to convert. Okay, this is kind of like the moles, the dimensional analysis that you used to do in chemistry, because what I'm going to do here is, for instance, if I want to know what 90 degrees is as a radian value, all I have to do is take 90 degrees and multiply it by pi over 180, because all I've done here is multiply it by 1 degree. Okay, and so now I know if I just do a little bit of simplifying here, this is going to just be pi over 2. Okay, it would be 90 pi over 180, or simplify to pi over 2. So in order for me to convert from degrees to radians, I'm going to take the degree value and I'm going to multiply by pi over 180. Okay, now going the other way, it kind of works the same way. We're still going to take that one fact that we have, that we know that pi radians is equal to 180 degrees, but now I want to know what 1 radian is equivalent to in degrees. So I'm going to divide both sides by pi radians. Okay, so I know that 1 radian is going to be equal to 180 degrees divided by pi, which, funny enough, that actually equals out to about 57 degrees. It's got some decimals in it, so it's about 60 degrees, kind of like what you saw, because 60 degrees would go into 180 3 times, and that's about how many times we went around with our pipe cleaners. Okay, so if I wanted to take something and I wanted to make it from radians into a degree measurement, so it actually made sense to me in the real world. So for instance, if I take pi over 6 and I want to convert that, I would take pi over 6, and instead of multiplying by pi over 180, I would multiply by this ratio, 180 over pi. And I have to do a little bit more work here, but you're going to notice that the pi's cancel and 6 goes into 180 30 times. So I would know that that is equivalent to 30 degrees. Okay, and so if I'm trying to convert here, all I got to do is I'm going to take my radian value and I'm going to multiply by 180 over pi. Okay, and it's kind of, if you're thinking about it, if you're trying to go from a radian to a degree, you want to get rid of the pi. So you're going to divide by a pi, get rid of that pi, it'll cancel it out. And if you're trying to get from a degree to a radian, you know that you're trying to get a pi in there somewhere, so you're going to put pi in the top. So if you're going to make it into a radian, put pi in the top. If you're going to make it into degrees, put pi on the bottom. Okay, and so if you had something maybe a little bit more tricky, like trying to make 3 pi over 2, I would go ahead and I would just take this and times it by 180 over pi. And again, you're going to have to do a little bit of mental math here. Pi's are going to cancel. 2 is going to go into 180 90 times. So 3 times 90 is 270 degrees. So the next thing we're going to do is we're going to be graphing these angles in radians. And as tempting as it might be to turn it just, convert it into degrees and graph it the way you were, we're going to go ahead and learn how radians work on this unit circle, so that way it makes life a little easier when we have to find exact values. Okay, so the first thing we're going to do is graph pi over 3. Okay, and so when I think about this, the first thing I'm going to do is obviously sketch my unit or my coordinate plane, and I'm going to go ahead and label those angles I know. I know 0, I know pi, and I know 2 pi. And I'm going to go ahead, and what I'm going to do is I'm going to make this in terms of whatever that denominator is. So I'm going to make all of those so that there's something over 3. So I know this is 0 over 3, which is kind of silly to write, but this would be over 3. Remember, I have to multiply the numerator and the denominator, so this would be 3 pi over 3, and this guy would be 6 pi over 3. Okay, and I could go in here and I could think, because I look and I see in between 3 and 0 would be 1.5, exactly in between. So 1.5 pi over 3. So now I can look and I can decide, where is this angle going to fall? This is 1 pi over 3. So 1 is closer in between 0 and 1.5 than it is 1.5 and 3. So I could just go ahead and I can graph that angle in there. And then remember, we're going to show that that's the direction it went, because it was positive, and that's all you got to do. Okay, so let's think about something that looks a little more tricky, like negative 15 pi over 8. I'm going to follow the same steps. So I'm going to look here. I'm going to label what I know for sure. I know 0, I know pi, I know 2 pi. Then I'm going to go ahead and I'm going to write these values in terms of whatever denominator they gave me. So I'd have 8 pi over 8, 0 pi over 8, and 16 pi over 8. Now the only tricky part about this one is there's a pi, that's a negative sign. There's a negative sign in the front. And remember, all that means is instead of going counterclockwise, we're going to go clockwise. So you can just think about this as negative pi over 8, etc., 8 pi over 8, and all of that. Okay, and so if I think about this, we know that 15 is not close to 0, 15 is not really close to 8. If I went up here and in between 8 and 16, directly in between that would be 12. And so what I have is something that's close to negative 16 pi over 8. So I would be over here, And then I would say, though, instead of going counterclockwise, I went clockwise around and draw my arrow, and that would be that angle, negative 15 pi over 8. Okay, now what about 18 pi over 7? If I went ahead and did those same steps that I've been doing, and I drew my plane, and I knew that this was 0, and I would even go and skip ahead and say, oh, this is 7, so 7 pi over 7, and this would be 14 pi over 7, I would notice right here that this angle is bigger than just one rotation. So this angle is actually bigger than 2 pi, so it's because that would be 14 pi over 7. And so what I need to do here is find a coterminal. So because this one is bigger than 2 pi, I'm going to go ahead and find a coterminal angle. Okay, and remember, how I find a coterminal angle now is I either add or subtract 2 pi from that given value. And because I know that this is an angle bigger than 2 pi, I'm going to go ahead and I'm going to subtract 2 pi from it. Okay, so we already said 2 pi is 14 pi over 7. So I know that this one is coterminal to, it's equivalent to, it ends in the same spot as 4 pi over 7, which is way smaller, a little less scary. So now when I'm looking at this, 4 is in between 0 and 7, so it's up here on the top. In between 0 and 7 is 3.5 pi over 7, which means that my angle is going to terminate in quadrant 2. And there we go. So one of the biggest things that we did here is we were looking for those patterns, and this next GIF kind of gives you those patterns. It's going a little fast, so I'm going to let it go through a couple times, but if you notice what it starts with is it starts with a 0, and then it just divides the circle up. So this time it divided that half circle into 6 parts, and it just named all those parts. So this they did over 2's, then over 3's, then over 4's, because they divided it into 4 parts. And then I don't think we went to 5. No, 5 was silly. Okay, and then 6, and then that was it. Okay, so if you can figure out those patterns when you're graphing them, even if it's something icky like a 7, you can still figure it out. And if you notice here, we could have technically simplified a few of these, like 2 pi over 4 or 3 pi over 6. That would just be pi over 2. So really what radians are is dealing with a lot of fractions. So if you're not feeling comfortable with fractions, time to bust out those flashcards.